Miss Humbert here. Today we're going to be doing Unit 8 Quiz 4 review. So we're going over what you need to take that quiz. So starting off with, let's just do a review of the Pythagorean theorem. So we're given the A and B and we want to find the C. So since we know the A and the B represent our legs. So I'm going to have A squared plus B squared is equal to C squared. Well, 10 squared is 100, and 24 squared is 576. Now that's going to be equal to C squared. So I end up getting that C is equal to the square root of 576. Now I want to take the square root of it so I can simplify it down to solve for C. So now I'm going to go ahead and break down 676, when you add those two together. 676. So when I do that, I end up getting 24 and 24, and you can continue to break those down, but notice I have two pairs. So actually, the square root of 676 is 24. So our simplified radical is 24 since it is a perfect square. Likewise, the approximate decimal is 24. So let's take a look at number 3. So for number 3, I have 6 squared plus 12 squared is going to be equal to my C squared, whatever that's going to become. So 12 squared is 36, or sorry, 6 squared is 36, 12 squared is 144, and that's going to be equal to C squared. So C ends up being equal to the square root of 180. When you add 36 and 144, you get 180. So now we're going to go ahead and take the square root of that number. So I see that it ends in a 0, so I know it's divisible by 10. So I have 18 and 10. Well, 10 I can break down to 2 and 5. 18 I can break down to 9 and 2, and then 3 and 2. So I notice I have a pair of 3's and a pair of 2's, and my 5 is going to be left underneath the radical because it doesn't have a pair. So then my answer is going to be 3 times 2 square root of 5. Well, 3 times 2 is 6, so then that's going to be 6 square root of 5. So to get the approximate decimal, what I'm going to do is 6 times the square root of 5. Now when I do that, I get 13.42. You might want to do yourself the favor of making sure you can type your answer in and that you know how to do that on the calculator. Please be careful of your rounding when you do that. So taking a look at number 3, we know a leg and we know the hypotenuse. So we're going to have to actually solve for a leg. So I have A squared plus 7 squared. Now A and B, it doesn't matter which one you choose for which. The only thing you need to make sure of is when you have your hypotenuse. So your C always sits across from your right angle, and your A and your B are always going to touch the right angle. So I have A squared plus 49 is equal to 16 squared, which is 256. So now I need to solve this for A squared. So I'm going to subtract 49 from both sides, and I get A squared is equal to 207. So I'm going to go ahead and take the square root of both sides. So I need to break down that 207. So I start by dividing it by 3. And when I do that, I get 69. And then I'm going to break that down again by 3, and I get 3 and 23. So I notice that I have a pair of 3's that I can take onto the outside. And then left underneath the radical is that 23. So then I'm going to do 3 times the square root of 23. And when I do that, I get 14.39. So that's your simplified decimal for number 3. Let's take a look at number 4. So for number 4, we know one of our legs and we know the hypotenuse. Remember, the hypotenuse sits right across from that right angle. So what we can do now is we can calculate out using the Pythagorean theorem. So I'm going to have 6 squared plus b squared is equal to 10 squared. Well, 6 squared is 36 plus b squared is equal to 100. So I'm going to subtract 36 from both sides, and I get that b squared is equal to 64. So now I need to take the square root of both sides. Well, the square root of 64 is 8. So 64 fully simplifies down into 8. So since it has a perfect square, both our simplified radical and our approximate decimal have the same number. Now, let's take a look at number 5. So for number 5, we want to determine if it's a right triangle. So what we're going to do is take the two smaller sides, add them, and set them equal to each other. So 8 squared is going to give, plus 15 squared gives me 289. 17 squared is 289. Again, I suggest typing this in the calculator along with me so you know you're doing it correctly. Since they are equal, it is a right triangle. Now let's take a look at number 6. So for number 6, again, you're going to take the smaller two sides, square them, and set them equal to the larger side. So 7 squared is 49 plus 144 is equal to 256. Well, when you add those two together, you get 193, and that's not going to equal 256. So no, this is not a right triangle. Let's take a look at number 7. You're about to see some beautiful drawings on my part. So here's the tree. Okay, we're going to have a ladder that's 45 feet long standing up against that tree. That tree extends 36 feet from the foot of the tree. So we want to figure out how high up it is. So let's go ahead and do that. So this right here is going to be our right angle. So that makes 45 our hypotenuse. So x squared plus 36 squared is going to be equal to 45 squared. So then I get x squared plus 1,296 is equal to 2,025. So then I'm going to subtract 1,296 from both sides. And when I do that, I end up getting 729. So now I'm going to take the square root of both sides. So when I do that, I'm going to get the square root of 729. So we need to break that down. So I start by dividing it by 3, and then I get 243. I divide it by 3 again, and I get 3 and 81. 81 breaks down to 9 and 9. 9 breaks down to 3 and 3. So I have 1, 2, 3 pairs of 3s with nothing left over. So 3 times 3 times 3 is going to give me 27. And everything is labeled in feet. So since it's a word problem, I want to make sure I label it feet. Now, let's take a look at number 8. We want to find the distance between those two. So I have x1, y1, x2, y2. So then I'm going to go ahead and plug that into the distance formula. So I have x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. So 3 minus 2 is going to give me 1 squared. 7 minus 0 is going to give me 7 squared. So 1 squared is 1, and 7 squared is 49. So what that gives me is the square root of 50. So I'm going to go ahead and break down 50 into pairs. Well, 50 divided by 2 is going to give me 25. And 25 I can break down to 5 and 5. So I have a pair of 5s that I can take out. And then left underneath the radical is 2. So 5 square root of 2 is the distance between those 2 points. Now let's do the same for number 9. So we have x1 and y1, x2 and y2. So I'm going to go ahead and plug that in. So I have x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So 9 minus 5 is going to give me a 4. 6 minus 3 is going to give me a 3. So 4 squared, I'm going to get 16. 3 squared, I'm going to get 9. So then I add those two together and I get 25. The square root of 25 is 5. So 5 is my final answer. I do want you guys to make sure the numbers after you square them should always be positive. You should never end up with a negative number underneath your radical. Now, let's take a look at number 10. Number 10 is the same thing. They just put our points on a graph. And it doesn't matter which one you choose as x1 as long as in the same parenthesis you have y2. So I'm just going to do it like that. So I have x2 minus x1. When you subtract a negative, it becomes plus a positive. y2 minus y1. So then I'm going to get 6 squared plus 2 squared. So then I end up getting 36 plus 4. Add those together and I get the square root of 40. So now I need to break that down. So 40 can be broken down to 4 and 10. 4 I can break down to 2 and 2, and 10 I can break down to 2 and 5. So I notice that I have a pair of 2's that I can take out, and left underneath the radical is 2 times 5, which is 10. So 2 square root of 10 is our answer for number 10. Taking a look at number 11, what we want to do now is calculate the distance between those 2 points. So, doing that, we have x1, y1. Again, remember, it doesn't matter which order you pick. So I have x2 minus x1 and y2 minus y1. Each of those are squared. 6 minus 2 is 4. 4 minus 1 is 3. So 4 squared is going to be 16, and 3 squared is going to be 9. So you add those two together, and again, you're going to get 25. Square root of 25 is 5. Last but not least, let's take a look at our last two word problems. So we're talking about a Boeing 747 flying 850 miles before refuel. Suppose the plane is flying from Minneapolis, so I'm just going to draw Minneapolis right here, to Denver, which I'm going to draw down here. So they need to go 600 miles west and 225 miles south. So what you notice is because we go directly from west to south, we can form a right triangle. So we can actually use the Pythagorean theorem. So 600 squared plus 225 squared is equal to x squared. So when you add those up, you end up getting x squared is equal to 54,225. There we go. So then I'm going to actually have you take the square root to get the approximate decimal on this one. And when I get the approximate decimal, it's 232.8. Well, 232.8, is that less than the 850 miles? Yes, so it can go the whole way without refueling. All right, last word problem here. Miss Carlson's biking to school. She's going 7 miles east and 24 miles south. So again, because she's going directly from east to south, it forms a right triangle. So we can use the Pythagorean theorem. So 7 squared plus 24 squared is equal to x squared. So when we add those two together, so that's going to be 49 plus 577, which is going to give us 625. So let's go ahead and break this down into pairs. So x is equal to the square root of 625. Well, I see that it ends in a 2, 5, so I know I can divide it by 25. And when I do that, I end up getting 25. So since I have a pair of 25s, 25 is actually my answer. And the label on that is miles, so she goes 25 miles to work. That concludes your review video. Let me know when you're ready for the quiz. Thank you for listening.